If you followed along so far, you may have wondered whether Ruby has a concept comparable to Java's interfaces, where we can give the signatures of methods and use that to indicate relationships between classes. Ruby has something slightly different and in some ways more powerful, and this concept is called mixins. Mixins are modules whose methods, instance methods, and constants can be included or mixed into a class definition. And then the methods defined in the module are available inside the class as if they had been defined right there. And an example of this is in the standard library. There's a module called Comparable, and this module defines a number of operators via methods for less than, at most, at least, greater than, and so on and so forth. And it defines these operators in terms of a special operator, which is defined as follows: A compared to B gives the result nil if A and B are uncomparable. An example of this is if they are of different types. It gives -1 if A is less than B, according to whatever semantics you want to assign to this operator. It returns 0 if A and B are deemed equal, and it returns 1 if A is greater than B. So what we can do is mix the comparable module into our class, and in our class then define the comparison operator, and then benefit from the comparable module's definition of all of these operators in terms of the one comparison operator that we can override. Because mixins exist in Ruby, the terms type and class aren't equivalent as they are in some other object-oriented languages. Rather, in Ruby, the type of an object is defined by all methods to which O responds. And these methods can come from whatever you define in the class itself, or from modules you mix into the class. And this distinction between class and type is the source of the term duck typing, which is often used in the Ruby community. To describe the type of an object, you have to understand to which methods the object responds. And so the saying is, if it quacks like a duck, it's a duck. And so in a concrete example, let's make the entry objects comparable. To that end, we mix in the comparable module and implement the comparison operator. And for simplicity, what we'll do is we will deem two entries equal if their dates are equal. So the dates at which they were created, if they are equal, then we will consider the two entries equal. So we start our class definition, or open it up, and we include the comparable module from the standard library. And then we define the comparison operator, which receives another object to compare to. So we are comparing the current instance of the entry class with another that is handed to us with the comparison operator. And the first decision we have to make is when we return nil, and we want to return nil unless the other object is of the class entry. So we only want to proceed with the comparison if both objects are of class entry. If they are, we know that both of them have a date attribute, And then we just reuse the comparison operator that is already defined in the standard library for date instances. And so what we return is simply the test whether date of our current instance and the other date we have been handed in the comparison operator, whether they compare favorably. So what we do is we reuse the comparison operator from dates type. Back in the IRB, I have started a session in which I have defined the author class as we've introduced it before. And Bilbo Baggins here is again the author we are working with. I've also defined the entry class. As you can see here, I am mixing in the comparable module, and the rest is basically as in the past, including the initialize and toAs methods. And then you can see I have defined the comparison operator. It returns nil unless the other parameter is also an entry. If it is, we compare the date of this entry instance to the date of the other entry instance. I've also defined two entries. E1 is one with the headline there and the body and back again. E2 has the headline and now and the body on to the next adventure. And now we can see if the mixin does work as we expect. So let's check if E1 is equal to E2. And we get back false, because clearly they have been defined at different times. Now, is E1 equal to E1? Yes, it is. Is E1 greater than E2? No, because E1 was actually added before E2. So we should have true if we say E1 is less than E2. And this again shows the power of the mixin. I never defined anywhere the equal and greater and less than operators. All I had to do was to define the general comparison operator, and everything else was taken care of by the comparable module, which I have mixed into my class. We'll now use a second mixin, namely the enumerable module, to make block objects enumerable, meaning that we can iterate over them individually. And that will have the added benefit that we can rely on methods such as sort, map, and find, which all come together with the enumerable module that we mix into our class. So as an example, we would like to create a new blog and push a number of entries onto the blog. And then we would like to use the each method to iterate over the blog entries, so that for each entry we can execute some Ruby expression. Here I've just chosen to use puts to print out the corresponding entry. And remember from our studies of the array data structure and the hash maps, when we use the each method, we can supply a block of code that is executed for each entry of the data structure. And if we implement the each method of the enumerable mixin, we have the same effect, and we can benefit from all the methods the enumerable module brings along with it. So let's try this out. If we want to mix in the enumerable module, all we have to say in the blog class is include enumerable. And then we have to define the each method. Now remember how each is to be called on the blog class. So remember, we give a call to each on the blog, and then we specify a block of code to be executed with each entry of the blog. Because we store entries in an array, we can reuse its each method to implement our each method. And that's exactly what we do here. So what we say is, for each entry, we execute this expression or this block of code. And what we see here is the yield statement. And what this does is it hands control from the current place to the block that was supplied to each. So remember, when we called each on the block, we supplied a block of code. And this block of code is where we yield control to. So in fact, whenever we find an entry in our array of entries within the block, we yield control to the block of code supplied with the each call for the blog. And that's our implementation of the each method for the blog. Let's illustrate this with an example. We are creating a new author here, Bilbo, and 3 entries. The first is a regular entry, the second is a warning, and the third one is a scream. And then we create a new blog and push onto it the scream, the warning, and the entry. And then we use the each method we have just defined for the blog class and supply to it a code block which for each entry is supposed to print out its author. And we'll call this the code block 1. Now internally, what you see is inside of the blog object, we have the entries array here, and in it we have the scream, the warning, and the regular entry. And now we can iterate over each of the entries, and we yield control back to block 1. So we execute block 1, where we substitute x for the expression e, or the object identifier e, in block 1. So the net effect of this is that we execute 3 put statements. The first one with s, so puts s.author, then w puts w.author, and e puts e.author. By defining the each method and using the enumerable mixin, we get a number of methods that are extremely useful. For instance, we can now call sort on the blog, and we can do so not only because of the each method and the enumerable mixin, but also because we have defined the comparison operator for entries. So in effect, we're using both the enumerable mixin and the comparable mixin together to benefit from the sort method that is now automatically defined for our blog. We can also use the group by method, which allows us to collect entries in groups. Here the example shows that we group them by the name of the author. So we say they are all collected into hashes that are keyed by the author name. So the call group by returns a hash, and the entries of the hash are keyed by the author name. There's also a method called all ? Which allows us to test, for instance, whether all entries in our blog are warnings. And finally, as another example, we have the count method. It allows us to return or obtain the number of entries for which a particular predicate holds. And the predicate here says, is the entry a scream? So we would count here the number of entries in the block of class scream. As you can see, using mixins gives us a broad range of behaviors that we can incorporate into classes without having to do a lot of work on our own. So in the IRB, I have defined class blog, this time with the mixin for enumerable. And you can see the each method defined as we just discussed. So for each entry, we yield control to whatever the block is that is applied to this each method. We'll start by defining a few authors. So Bilbo, Gandalf, and Gollum. And then we create entries. So E is a regular entry by Bilbo. W is a warning by Gandalf. And S is a scream by Gollum. And now we create a new block and push onto it the scream, the warning, and the entry. So this gives us a block with 3 entries. And now we can iterate over each of the entries in the block and print the author's names. So what you see here in the output, we have 3 author names printed, Gollum, Gandalf, and Bilbo Baggins. And the remainder of the output is simply the result of the expression, which is the block itself. Now, let's say we allow Bilbo to make another entry. And add it to the block. We can now use the additional methods the enumerable mixin gives us, such as sorting and grouping. We'll try out grouping first. So with this, we group the block entries by the author's name, which should give us a hash indexed by the author. And in fact it does. We see that the author Gollum has 1 entry, Gandalf has 1 entry, but Bilbo Baggins actually has 2 entries. And we see that this is a hash. And this hash is indexed by the author name. And each value indicates an array collecting all of the entries belonging to that name. Let's try out sorting. Let's first see the order of entries in our blog directly. So we see that Gollum's entry is first, followed by Gandalf's, followed by the two entries Bilbo has made. If we call b.sort, we get back an array that is ordered by the time at which the entries were made. So we see now that Bilbo's entry is first at 12:17 p.m., Gandalf's entry is second, Gollum's entry is third, and Bilbo's second entry is fourth.